Greetings, ladies and gentlemen. Thank you for joining me. This is TJ's Maths and Further Maths Adventures. In today's presentation, we continue with our solutions to WAEC 2024, and this is mathematics. This is paper 2, question 12, section B. Under this question 12, we have question A and question B, respectively. Question 12A reads, in the diagram, we have a diagram here. PR is a tangent to the circle, center, or at Q. So we have a diagram here that is a circle, and we have a tangent to that circle as P to R, okay, at point Q. The angle POQ is 56 degree. POQ is given as 56 degree. And PO intersect SQ. PO intersect SQ at V, such that angle SVP is 109 degrees. We are asked to calculate number one, angle TQP. Angle TQP means the angle is at P. TPQ, which is the whole of this angle here. Okay? And Roman numerals 2, angle QTS. QTS, that's the whole of this angle here. Okay? So, for us to find the whole of this angle, we have to find this small angle here. Okay? That is the first question. Question 2, we are asked to simplify 2n squared minus 3n minus 2 divided by 2n squared plus 3n plus 1 times n squared minus 1 divided by n squared minus 4. The first thing for us to do is to identify this question A is from which topic. Of course, this is from circle geometry or circle theory. And of course, question B is from algebra. Okay, so let's look at how we can solve this question A and question B. Let's write down the solution here. Solution to A now. The first thing for us to do, we know that if this is the center, any point you pick to touch the circumference will be the same. Any length, if I move to this point, the length will be the same to this point because this is the radius. And from radius from the center of the circle are equal. Okay, so from here to here is the same, from here to here is the same, meaning this is an isosceles triangle. So it means this angle here and this angle here are the same. I can say let here be x, because base angle of an isosceles triangle are equal. It means angle OTQ is the same as angle OQT, which is equals to x. The reason is base angles of an isosceles triangle are equal. Base angle of an isosceles triangle are equal. That's the reason. So I can easily find x now. So it means x plus 56 degree will be equals to 180 degree. Reason is sum of angles in a triangle. Sum of angles in a triangle. Sum of angles in a triangle sum up to 180 degrees. So this will be 2x plus 56 degree will be equals to 180 degrees. So we can easily find x. 2x now will be equals to 180 degrees minus 56 degree. 2x now will be 180 minus 56 degree will be 124 degrees. Divide both sides by 2. And x now will be 2 here, 1, 2 here, 6, 2 here, 2. That will be 62 degree. So the base angle of this isosceles triangle is 56 degree. As I said, these radius are of equal length. Okay. Next now is we can easily find this angle, the first question now, because we are asked to find angle TQP. Okay, let's click here to find that. We recall that the radius is always perpendicular to the tangent. So here will be 90 degrees. Here will be 90 degrees because the radius is perpendicular. Reason, So it means angle OQR is 90 degrees. Reason is radius is perpendicular to a tangent. Radius is perpendicular. Perpendicular means 90 degrees. So I know this angle here. I can easily find that angle TQP now. So angle TQP now will be equals to this angle here, which is 90 degree plus 62. So angle TQ now plus to be 90 degree plus x of course is 62 will be equals to 180 degree. Reason is sum of angles on a straight line. Sum of angles on a straight line. Sum up to 180 degrees. So I can easily find the angle at Q now. Angle TQP now will be 180 degree minus 90 degree minus 62 degrees. Finally, angle TQP will be equals to 180 degree minus 90 is 90. 90 minus 62, of course, is 28 degree. So the solution to this Roman numerals 1 is 28 degree. Next is for us to find angle QTS, which is the whole of this angle now. We are looking for the whole of this angle, given that this small angle here is 62. Okay? To do that, let's move here. Let's move here. We realize that if this angle at the center here is 56 degree, okay? Since angle, we're solving solution to Roman numerals 2 now. Angle TOQ is equals to 56 degree. Half of that angle now will give us the angle that is at the circumference here. It's a theory too. So it means angle TSQ will be half angle TOQ. Angle at the center is twice angle at the circumference. That's the reason. Angle at the center, is twice angle at the circumference. So that's the reason. So it means to find this angle here, we take half of angle at the center here. So angle TSQ now will be half times 56 degree. Half of 56 degree will be 2 here, 2 remainder 1, that will be 2 here, that's 8, that will be 28 degrees. So it means this angle here is 28 degrees. So we can easily find this remaining angle here because we have this angle here as 109. So since we don't know this angle, let it be y. We can say let this angle be y. So it means y now plus 109 degrees plus the value of x, which is 62, will be equals to 180 degrees. That's sum of angles. This is a triangle. Sum of angles in a triangle. So let's clean here to find the value of y. Y now will be, we can add 109 plus 62. That will be 171 plus 171 will be equals to 180 degrees. So y now will be 180 degree minus 171 degrees. So y will be equals to 9 degrees. So this angle here is 9 degrees. So we can easily find this angle, the whole of this angle here now. That is angle STQ. Yes, we can find angle STQ. Therefore, angle STQ now or SQT, we can say angle angle QTS, whichever way. Angle QTS now will be equals to the whole of this angle here now will be x plus y, x plus y, x plus y. Yes, it will be x plus y, given that y is x is 62 degree before plus 9 degrees. So this will be 71 degrees. So the whole of this angle here is 71 degrees. Okay, given that y is 9 degrees and x before it was 62 degrees. So if we sum this and this, it will give us the angle, the whole of this angle here. Okay, so this is the solution to 12a. Let's clean the question so that we can solve 12b. Okay, so 12b now, solution to 12b. The 12b is 2n squared minus 3n minus 2 divided by 2n squared plus 3n plus 1 times n squared minus 1 divided by n squared minus 4. So we can factorize this. 2n squared times minus 2 is minus 4n squared. Two factors of minus 4n squared that can give us minus 3n will be minus 4n and n. So this will be 2n squared minus 4n plus n minus 2. We do the same here. 2n squared times 1 will be 2n squared. Two factors of 2n squared that can give us 3. It will be n plus 2n squared plus 2n and plus n plus 1 times, this is difference of 2 squared. So n squared minus 1 is the same thing as n plus 1 in one bracket, then n minus 1. This is difference of 2 squared. The same thing here, we can apply difference of 2 squared as well. This will be n plus 2 in bracket, then n minus 2, using difference of 2 squared now. Okay, so let's factorize this. We can group this like this and factor out what is common. What is common here is 2n into n minus 2. What is common here is plus 1 into n minus 2 divided by 2n into n plus 1, that's common, then plus 1 into n plus 1 times n plus 1, n minus 1 divided by n plus 2, n minus 2. Realize that what we have in the bracket are the same, so we can pick what we have outside. N plus 1, 2n plus 1 into n minus 2 divided by 2n plus 1 into n plus 1 times n plus 1, n minus 1, n plus 2, then n minus 2. Okay, so clearly here we can, this will divide this, which is 1. Again, this will divide this, which is 1. Again, this will divide this, which is 1. At the end, we'll be left with, let's clean here. At the end, we'll be left with, in our numerator, n minus 1 divided by, in our denominator, n plus 2. So this will be the solution to B. Thank you for watching. Please do share this to your learned colleagues and don't forget to subscribe to my YouTube channels. Thank you.